What's up, people who will have to deal with the lasting effects of climate change? Today, we're going to talk about multiplying and dividing rational expressions. Again, rational expressions are just a fancy way of saying things that you don't like. Fractions. These fractions right here. And I've got good news for you. We're going to do multiplying and multiplying. We're not actually going to divide. I'll leave it up to you. You decide if you think it's dividing or not. But because we're dealing with fractions, remember, you don't actually divide by fractions. You just multiply instead. So we'll look at it. But hopefully this isn't too painful for you. But we'll see. I'll leave it up to you. You can let me know in the comments below. Or you can just like that video. Maybe even subscribe. Hit the bell icon for notifications. That way when I upload new videos every day, sometimes 3 times a day, you can go watch them and be like, haha, I love math so much. It's so great. These are my favorite videos. I could watch them all day. I'm going to share them with my aunt, my uncle, and my cousins who are struggling with math. My everybody. I hope my dog watches them. That would make me so happy. All right, let's go talk about multiplying and dividing rational expressions. We're going to start with some steps. This is misleading. Let's look at the steps. Same first step. Factor the top and the bottom of each fraction. So just factor everything. Just everything that you can see. Everything, Simba. As far as you can see from here on Pride Rock, factor it. And I know what you're thinking. Mr. Barton, when you said, if I can't factor, I'm going to have a hard time doing the rest of this class. When you said that in Unit 2, I thought you were fibbing. Mr. Barton, I think now might be a great time to tell you that I never actually learned how to factor. Well, lucky for you, those factoring videos are still available. They're still up. You can go watch them. If you go look at my YouTube channel or you go onto Canvas and click on those old modules, you can go back and learn them again. And what's even better news for you is you can go back and you can look at those old factoring homeworks you didn't do, and they're still there. You could still do them and turn them in for partial credit to get your grade up, and you'd learn how to factor. Isn't that just the best news you've heard all day? So step 1 is factor. Step 2 is state the restrictions. This means we're going to set the bottom equal to 0, and then we're going to say don't use those numbers. Set the bottom equal to 0. And solve for x, of course. Okay. Now, we're either going to multiply, or this is really only for dividing. We're going to change the division sign to a multiply, and then we're going to flip the second fraction over. If you're doing a multiplying problem, you skip step 3. This one doesn't apply to multiplying. This is only for dividing, right? You can't change a division symbol into a multiply symbol if there is no division symbol, right? Then, step 4, it says simplify diagonally. Step 5, simplify top and bottom. Step 6, multiply everything back together. Step 4 and 5, you can kind of think about that as all one step. You just simplify, and it doesn't really matter which fraction you're looking at. Anything is fine. So let's go look at a few example problems. We're going to start easy with multiplying. So we'll skip step 3 for a couple of slides. Then we'll look at the division, which makes things a little bit more complicated, but it's all right. You have a great math teacher who's here to love and support you and teach you how to do these problems. So let's go look. I apologize for the blurry pictures. The person who made these decided it was a great idea to use JPEGs. You know, there's no accounting for taste. Mr. Barton, why did you take the time to change them and make them look nicer for us? Hey, listen, I don't like the tone of your voice, kid. If you would just sit down and listen how to do this, you'd be in a lot better shape, okay? I don't need your criticism. This is hard work. All right, so let's go ahead and read our steps one more time because we forgot them. Step 1 is factor. Can I factor this? Well, there's no pluses or minuses, so Not really, right? There's not a GCF here or here or here or here. We don't have 2 terms or 3 terms to do factoring, like simple factoring or complex factoring or factoring by grouping. This is not factorable. So we're not going to worry about factoring for these first 2 examples. Okay? Step 2 is state the restrictions. All right, that we can do. So we're going to set both of these bottom terms equal to 0. So we have 21y cubed equals 0. All right, we're going to divide by 21. All right, 0 things put into 21 groups. How many things are in each group? Well, there are no things, right? So 0 still. Y cubed equals 0. Then we take a cube root of both sides to cancel the exponent. The cube root cancels the cubed, and y equals what number times itself 3 times is 0? Oh, 0. So y equals 0. Anytime you have a monomial, meaning a term without pluses or minuses in it, and you have a variable, that variable will always equal 0. So without even looking at this, I can tell x equals 0 is a restriction. Okay, so our 2 restrictions are y should not be 0 and x should not be 0. Okay, now what we're going to do is we're going to erase this work so it doesn't look so scary. Erase these circles so that we can read better. And we're going to multiply straight across. And then we'll reduce using what we know about, or actually, hang on, let's back up. Let's not do that because the numbers are going to get too big. Here's where you get to apply a little bit of finesse. And I know that's something that you only know in terms of finessing one another, meaning hustling or taking advantage of someone. You can think of it in the same way. We're going to take advantage of the fact that we can multiply and divide in whatever order we choose because they're basically the same operation. So we are going to do some canceling. Do you see this 8 and this 16 on the bottom? Just because they're not stacked doesn't mean you can't reduce them. You can reduce them. So what goes into 8 and 16? Well, 8. 8 goes into 8 one time, and 8 goes into 16 2 times. Same thing with 7 and 21. 7 goes into both of these. 7 goes into 7 one time, and 7 goes into 21 3 times. If we look at our y's, we have 2 y's on top and 2 y's on the bottom. So these 2 y's cancel 2 of these y's and leave us with 1. Then this single x on the top can cancel 1 of these 3 x's. So this goes away, and we reduce this by 1. Now, what we have is 1 over 3y times 1 over 2x squared. And now this is a lot easier. Now we can just multiply straight across. 1 times 1 is 1. 3 times 2 is 6. And then y and x squared aren't like terms, so we can't multiply them. So we just bring them down. So x squared comes down, y comes down. And our answer is 1 over 6x squared y. Cool, pretty easy. All right, let's look at this second one. All right, right here, we need to set this equal to 0. Again, we should know the answer already, but I'll show you just in case. Set this equal to 0, divide by 15, divide by 15, y equals 0. So y does not equal 0 is one of our restrictions. And then we remember what Mr. Barton said. Oh yeah, anytime we have a monomial or something that's just multiplying, no adding or subtracting, the variable in there cannot be 0 is the restriction. So x cannot be 0. Let me show you just one more time in case you don't believe me. We set the denominator equal to 0. We divide by 2. X cubed equals 0. We take a cube root. And then x equals 0. So that's our restriction. All right. We have our restrictions. We're very careful about that. And now we get to do the fun part, which is simplifying. So let's see. Is there anything we can reduce? Well, this 1x can cancel one of these x's. So these cancel, and we have 2 left here. This 1y can cancel one of these y's. So now we're at 1. And then some numbers can reduce with 15. So 3 goes into 15. 3 goes into 3 one time. 3 goes into 15 5 times. Oh, look, 5 reduces with 5. 5 goes into 5 one time, and 5 goes into 5 one more time. So on the top here, we have just 1 left over 1, and this y canceled. So this is just 1. Everything here canceled. Times, we have 1 y to the first over 2 x squared. So 1 over 1 is just 1. This goes away. And then this is our answer. We have y to the first over 2x squared. Done. Perfect. All right, let's look at some of the harder problems. I think these are actually a little bit more straightforward just because it's a little more clear how things cancel. But we'll take it step by step. So again, our steps. Step 1 is factor the top and the bottom. This looks factorable to me. Not the tops. The tops are going to be the same. So 3x, put that on top, times x minus 6. Those aren't factorable. Here, though, we can factor x squared minus 2, x minus 24. So we look at the factors of 24 and do simple factoring because there's 1, 2, 3 terms, and our leading coefficient is a 1. So we have 1 times 24, 2 times 12, 3 times 8, 4 times 6. And we ask, how can we make a negative 2? Well, we could do negative 6 and positive 4. And if I multiply those, I get negative 24. So this is going to factor to x minus 6 times x plus 4. Then we have to factor this. Unfortunately, we can't do simple factoring, but good news is it's even easier than that. We can just factor out a GCF. So 3 goes into 6 and 9. So we're going to take a 3 out. And then these both have an x. And we have to take out the lowest power. So we'll take out x to the first, x to the first. So we're going to take out a 3x from this. 3 goes into 6 2 times. We had 2 x's. We took 1 out, so there will be 1 left. 3 goes into 9 3 times. And we had 1 x, but we took it out, so the x's cancel. So this is now factored. All right, everything's factored. Now we need our restrictions. So we set each of these factors equal to 0. X minus 6, x plus 4, 3x, and 2x plus 3. Set them all equal to 0 and solve for x. So x minus 6 equals 0. X plus 4 equals 0. 3x equals 0. And then I'll do 2x plus 3 at the end. Plus 6, those cancel. X equals 6, that's a restriction. X cannot be 6. Subtract 4, x equals negative 4, that's a restriction. X cannot be negative 4. Divide by 3. Oh yeah, it's a monomial, so x equals 0 is the answer. We didn't have to do it, but we will, just to prove it to ourselves. So x cannot be 0, and then we do 2x plus 3 equals 0. This one's a little more work. Subtract 3. 2x equals negative 3. Divide by 2. X equals negative 3 over 2. So that's our last restriction. X equals negative 3 over 2. Other does not equal. All right. So now we have all of our restrictions. Now we get to simplify. And the rule is we can cancel anything on the bottom with anything on the top that it matches with. So x minus 6 can cancel with this x minus 6. They don't even have to be in the same fraction. It's just anything on the bottom can cancel with anything on the top. This 3x can cancel with this 3x. So everything on the top goes away and we're out of stuff to cancel. So on the top, we have, if it cancels, it's just 1. So it's 1 times 1 is 1 on the top. On the bottom, we have x plus 4, and then we have 2x plus 3. I believe that your homework is going to want you to multiply this out. So we have to do a little bit of foiling, but that's all right. We're big kids and we're not scared. So we're going to FOIL this. X plus 4 times 2x plus 3. So we're going to do x times 2x. That's 2x squared. X times 3 is plus 3x. We're done with the x. 4 times 2x is 8x. 4 times 3 is 12. Combine like terms in the middle. We get 2x squared plus 11x plus 12. And this is our denominator. So we have 1 over this thing. 2x squared plus 11x plus 12. And that's our answer. I'm not sure if it's going to have you multiply or if it will leave your answer like this. I don't get to pick, so you're going to have to live with whatever they give you. But I'm sure you'll have a multiple choice answer, so good luck. All right, let's talk about dividing because it's a little bit different. I think we have 2 division problems we get to look at today. So the steps are the same. We just need to do one extra step in the middle. So start by factoring everything. On the top here, we can take a 2 out because 2 goes into 2 and 6. So we'll have 2. 2 goes into 2 1 time. Bring down D. 2 goes into 6 3 times. On the bottom, this is simple factoring. So we look at the factors of 2. It's just 1 times 2. We need to get a positive 1. So we're going to do positive 2 minus 1. So this will factor to D minus 1 times D plus 2. Then here, we're going to look, we can't factor the top. All right, that's fine. So divided by D plus 3. On the bottom, we can factor that for sure, though. So we look at the factors of 2. They're still 1 and 2. Now we need to get a positive 3. So 1 plus 2. So this will be D plus 1 and D plus 2. All right. Now we need to get our restrictions. So we set all the denominators equal to 0. So we have D minus 1 equals 0 from here. D plus 2 equals 0 from here. D plus 1 equals 0 from here. And D plus 2, we already have that one. There's no need to do it again. So now we just solve. So add 1. D equals 1. Subtract 2. D equals negative 2. And subtract 1. D equals negative 1. And those are our 3 restrictions. So D cannot be 1. D cannot be negative 2. And D cannot be negative 1. All right. Now we need to do that mystery step 3. Let's go look at it one more time. Change divide to multiply and flip the second fraction over. All right. So what we're going to do is we're going to change this into a multiply symbol, and this fraction is going to get flipped. So keep this one the same. 2 times D plus 3 over D minus 1 times D plus 2. Multiply, flip this fraction. So on the top, we'll have D plus 1 times D plus 2. And then the D plus 3 goes on the bottom. All right. We need to go check our restrictions again because now we have a new denominator, so we get a new restriction. So after the flipping, you have to check and see if you get any new terms on the bottom that might give us new restrictions. So we do D plus 3 equals 0, subtract 3, and D equals negative 3. That's our new restriction after doing the flipping of the fraction. All right. We have all of our restrictions. We have our division flipped and turned to multiplying. Now we get to do the easy part of canceling. So d plus 3 cancels d plus 3. D plus 2 cancels d plus 2. D minus 1 and d plus 1 do not cancel because they're different. So on the top, we multiply 2 to d plus 1. So 2 times d is 2d plus 2 times 1 is 2. And then on the bottom, all we have left is d minus 1. And then this is our answer. All right, so 2d plus 2 over d minus 1 with the restrictions that d cannot be 1, -1, -2, or -3. Easy, right? Let's do one more just to make sure you're comfortable. So factor the tops and the bottoms. This can't be factored, this can't be factored, this can't be factored. Only this top can. So we look at the factors of 3. The factors of 3 are 1 times 3. To get a -4, they both need to be negative. So this top will be x minus 1 times x minus 3 over 2x divided by x minus 1 over 2. All right, let's look at our restrictions. We set the denominators equal to 0. So 2x equals 0. Divide by 2, divide by 2, x equals 0. We knew that because it's a monomial, meaning a one-term expression. So x cannot be 0. Do we need to do the 2? Whoops, I didn't mean to make that mark. Can we do that too? Well, if we try, 2 equals 0. Okay, 2 doesn't equal 0, and there's no x to solve for. So because there's no variable here, there's no restriction. We just don't do it because you can't get a restriction, right? No matter what value of x here, this 2 will never change. It's a constant, so it doesn't care what numbers we plug in. It will always be at 2, so there's no restriction. All right, now we do our flip and multiply. So we keep the first one the same, x minus 1 times x minus 3 over 2x. Change our divide to a multiply and flip this. So 2 over x minus 1. We have a new denominator, so we have to check for a new restriction. X minus 1 equals 0. Add 1. X equals 1. So that's a restriction. X does not equal 1. Now we do the last easy step, which is canceling. So x minus 1 cancels x minus 1. This 2 can reduce with this 2. 2 goes into 2 one time, 2 goes into 2 one time. So on top, we have x minus 3 times 1. So that's just x minus 3 because times 1 doesn't do anything. And then we have 1x times nothing, times 1. So that's just 1x or x. So our answer is x minus 3 over x with the restrictions that x cannot be 0 and x cannot be 1. And that's it. You're done. Easy. Just a quick 23-minute video with factoring, division, restrictions, flipping and multiplying fractions. Basically, it's just everything that you're terrified of in math. So I think you're going to have a really great time with this one. Make sure you leave a comment below telling me what a great time you had. If you need any help, hop in that WebEx and say, Mr. Barton, I could really use some help on this problem. I'm a little bit stuck. Or if you want to fail the class, you could sit there and do nothing. That's also an option. It's a terrible option, and your parents are going to be disappointed, but I'm not your mom, so talk to her about it. Until next time, have a great day, and I'll see you next time.